Bismillah ar-Rahman ar-Rahim. This is October 2020, 32 variant, question number 5. And what a question is, he given us the parametric questions given. You can see one is given x is equal to tan x theta, and one is given by him is y equal to cos square theta. And he mentioned that here. You know what this means? This means that answer is from till pi by 2 positive and till negative pi by 2. So it's the answer will be in the first quadrant and the fourth quadrant. Okay, make sure. All right, so let's start. Show that gradient of the curve at a theta is this much. So how we find it? Because you know gradient means dy over dx. This is my target to find. So let's start. So left hand side x, right hand side theta. So I will differentiate dx over d theta. And tan difference in all of you know secant square theta. Leave it here, dy over d theta, but it has a power. What we do always this kind of situation? Look, for example, I have a sine cube theta. How we do this kind of differentiation? First, bring power down. Power becomes 2, 1 less, and then into base derivative, that is a cos, and then into angle, that is a 1. Same story here. First power, so this 2 will come down and power of cos become 1. Into base derivative is a minus sine. At the end angle derivative, that is a 1. Theta, whether with theta is 1, you know it very well. So I got both derivatives very clear. Alhamdulillah Rabbil Alameen. And this is my target to prove. So I'm writing here by chain rule. And how we can do it? What is my target? Dy over dx. So I'm writing here dy over dx. I write here two fractions. This come in first numerator. This go in second denominator. Dy dx. And third variable used in the question. So x, y, and theta. X, y I used already. Theta left. Theta will come down and up. And this value I will get from here. I'm writing negative 2 cos theta sine theta. And this I get from here, but make sure theta up, x down, here, x up, theta down. So take reciprocal of it. I mean 1 over secant square theta. But is question over? Not at all. Not at all. So you know, students, I need a cos cube. It's working. What is sec? All of you know sec theta is actually 1 over cos. Or if I take reciprocal, so 1 by cos is actually equals to sec. Sorry. 1 by sec. 1 by sec is equal to cos theta. So it means this 1 by sec, 1 by sec. So 1 by sec, 1 by sec square. So this turned to be cos square theta. Or I replace this here, 1 by cos will flip up, same thing. And cos square into cos become cos cube. So alhamdulillah, Rabbil Alameen. First part completely done. So I'm not writing dy over d, I'm writing m. Why m, sir, is called gradient? You can ask me. I'm writing gradient here. So gradient of the curve, and this is proved. Alhamdulillah Rabbil Alameen. Part number next. So gradient, a curve has a
So,
maximum value.
cos Q,
Oh yeah, thank you
cos
very
Q.
much. Okay, thank you very much. Thank you very much. You are right. This was a square, but this is a cube. Thank you very much, dear. On right time, you said thank you. So proving is done. Now let's move on next. Okay, now the next part is saying the gradient of the curve has a maximum value at P. Okay, whenever, okay, here I want to give you an idea behind the scene. For example, this is an area of any rectangle, of any shape. For example, 2x to power 2 plus 4x. Or here, let's say minus. If I ask you, find out the minimum area, what will do? Not minimum gradient, not maximum gradient. Look, gradient has a maximum value. Here he asking us maximum gradient. Maximum gradient he is asking us at P. Okay. And that maximum gradient he asking that at that particular point, find out x coordinate. I repeat, the gradient of the curve has a maximum value at p. At p, find out exact coordinate. So first of all, maximum gradient I need to find, and that particular point I need to find x what. Okay, so this I'm trying to compare with that. Here, if I'm looking for find out the maximum area, here maximum gradient, here maximum area, what is technique? I will differentiate. Job number one, differentiate. I got derivative, put 0. Okay, I will put 0. Okay, done. Here I got x1. Is this x1 and that value 1? If I'm looking for area value, then I will plug in this one back in equation. I get an area value. But same story almost here. I'm going to discuss now. Job number one, this gradient equation I will take it, copy and paste. Okay, and now what I'm going to do, students, job number one, as I differentiate area here, so I will differentiate gradient here, dm by d theta. Okay, what is it? Can I do directly? No way. I have to do some extra work or product formula, because UV formula, this is U and this is V. So let's try to do that. So -2 sine theta, keep as it is, times 2 cos cube derivative, plus then cos cube theta as it is into this derivative comes here. Repeat, this u copy v derivative, then v copy u derivative, one by one. And what is this derivative? I discussed with you just now. First power comes down, power one less, then base derivative cos has a minus sign. At the end, angle and angle derivative is one you write or you don't write, no problem. Now cos cube copied, and what is the whole differentiation? -2 as it is, and sine derivative become cos theta. So alhamdulillah rabbil alameen, I have almost done. Simplify. How simplify? Negative into negative positive. I'm going to do 2 from here and 3 from here. I got a 6. Okay, and cos square theta, I copied sine into sine, I got sine square theta. What about this, students? -2 cos 4 theta ida, because cos into cos cube equals 4. And after that, you know it very well, I plug in derivative 0. Same, I will plug in derivative 0. Now after having this, what is my ultimate target? To get theta from here, and that theta which I will get it, I will plug in this equation. When I plug in it here, it will give us x value, which is our target. So let's start. So first of all, 2 common, cos square common. Here out of 6, 2 gone, 3 left. Out of cos square total gone, sine square left. So alhamdulillah rabbil alameen. Here 2 gone, out of 4 cos square gone, square left. So now either you remember, student, this will either this equal to 0 or the whole thing equal to 0. I will write both like this, and like this. My target, okay, this 2 will go under it. I get a cos square theta equal to 0. Take a root of both sides. I got cos is 0 where all of you know either cos is 0 pi by 2 above and 3 pi by 2 or minus pi by 2. Either here 0, either here 0. So it means I get 2 answers, pi by 2 and minus pi by 2. But for your knowledge, this answer is not in range. There's no equal sign even, not equal sign. So this is out of range. These both are out of range. I am just discussing with you, okay, in exam, when you observe that this is 0, so there's no need to waste time in this calculating. Because if I eliminate without explaining, then we'll ask me, sir, why you are leaving these answers. But I hope so you understood this point of view. Now we have 3 options. What? Option number 1, convert cos square into sine square. Second option, convert sine square into cos square. Third option, convert into tan. So sine cos square will go there. So it will turn to be this format. Cos will come under sine square, and sine square by cos square, you know, tan square theta. 3 will go under there, 1 by 3. So this is, I think the point is very, very clear. Now take the root of both sides. We have 2 answers. Okay, I'm writing both. So first answer, tan theta is 1 over root 3 positive. Second, I'm getting tan theta is equals to negative 1 over root 3. Why negative? Because when I take a root, plus and minus must come. So plus, I'm writing it here, and minus, I'm writing it here. Okay, after this, student, tan is a positive, tan positive. Tan positive in this quadrant and this quadrant. This is out of range because we have to stay in the boundary of pi and negative pi by 2. And this is my answer most probably. And what about this, students? Check it. So tan is negative where? Tan is negative here and here. So this is out of range and this is in range. So I will check this even. Okay, students, so let's try this one. So first of all, how to get this one? So have a look now. So tan inverse of 1 by 3, when I take a tan inverse, students, 1 over root 3, it gives me 30 degree pi by 6. Okay, and what about this same thing? And I said you many times, take alpha, don't take a negative sign, and type the same way, same thing, this value same, only sign issue, don't take that. So this is also giving pi by 6 here and pi by 6 here. Well, student, here I'll take a negative pi by 6. You ask why, sir? Because when I go anti-clockwise, angle positive, clockwise, angle negative. Because here I am going clockwise. Okay, this is out of range. Why, sir? Because if I go this way, these are bigger than pi by 2. Bigger than pi by 2. So this way I'm out of range, but this I will take it. So I have this angle, I will take a negative pi by 6. Now I have a two angles are there, students. So let's see how we can get it. 4-mark question, find exact coordinate of P. But look at here. This P is exact coordinate here. Common sense, this is coming here. It means X value is negative. Okay, I think you got my point. So I will plug in both values. So X is equal to tan theta. This equation, I will take it. This equation, I will take from here, cut, and I will bring down here. Paste one time here and one time here. So let's see now which is giving us the right answer. So I will plug in this here. X equal to 10 pi by 6. X is equal to 10 minus pi by 6. Okay. So when I type in calculator, so students, this is giving us 1 over root 3. Okay. And this is giving us negative 1 over root 3. And as I said you that this is my answer, this is not my answer. This is out of range because it is coming. So this is my answer. I will not put in this rectangle. So Alhamdulillah Rabbil Alameen, because this left hand side, if we have a right hand side, I will take the positive part. But here negative side. That is why. And what a question once again, find exact value of the x coordinate of P. And Alhamdulillah Rabbil Alameen. Sorry, this is my answer. And the question is completely